Hi everyone, hello. Welcome to Vedantu JEE channel, all the students. How are you all, guys? Well, especially to those students who are preparing for JEE 2021, that means the JEE that is going to happen next year. I welcome all of you, especially. Why? Because this session, the timing, as you all know, targets only for uh, those topics which are relevant for students who are targeting for JEE 2021. Or I should rather simply put it this way, students who are moving from 11th to 12th standard. Yes, this is specifically the batch which is going on for all of you on Vedantu's JEE channel. So I welcome you all. And for those students who are on the channel for the first time but are moving from 11th to 12th standard, let me tell you important informations before we go forward. Okay, guys? So stay tuned. A lot of problems we are going to solve based upon electrostatics. Okay, so guys, starting off with my introduction first. This is me, your Suri Sir. Yes, I'm also known as Mogambo on YouTube. Why? Because when you will crack the examination of JEE in future, Mogambo kush hoga. Now, let me tell you what is the timetable that we follow for students who are targeting for JEE 2021. That means next year. So, meet your teachers here, guys. This is Harsh sir, this is Arvind sir, and this is me. Harsh sir is your chemistry teacher. Arvind sir teaches you mathematics, and this is me for physics. Okay, so what is important to notice, guys, is the timing here, and I want you people to remember it. If you can't, put a timer, not timer but a reminder, that at 9 p.m. every day we meet for theory session, and at 8 p.m. on Wednesday, Monday and Thursday, or Thursday, Monday, Wednesday and Thursday, we meet for MCQs. Okay, guys. So on Monday and Thursday at 9 p.m. you meet her sir. Okay, and on Wednesday and Saturday you meet me. Okay, and apart from that, you meet Harvin sir on Tuesdays and Friday. Okay, cool. So please keep this in mind, and I'll tell you how else you can stay updated in a while. But if you are a student who's targeting very seriously for JEE 2021, so people, as you know that during this lockdown, neither our school nor our physical classes are going on. But you don't have to worry. At Vedantu, we have a batch specially targeting for JEE 2021. Yes, all those students who are moving from 11th to 12th standard, for all of you, the enrollment is free of cost for this batch, guys. So do not miss on this opportunity. This is a great thing to be a part of Vedantu's platform, not just YouTube. You can study with us for 2500 plus hours of live teaching, 45 plus teachers. All Vedantu's master teachers are there, 750 tests and 3000 assignments. And obviously, your doubts get instantly solved by your academic mentors. You can watch the replays and recordings of any class that you missed, and a lot of things, guys. Okay, so how you will enroll for this batch? All you have to do is follow this link, as I said, this link which is available in the description of this video. Okay, guys, so below this video there is a arrow on the right hand side of the video. Just below it, click on that. You will find the description, also the link for the batch which has been mentioned here. Okay, and as I said, if you want to stay updated with the channel itself, I want you to subscribe to the channel, and not just that, press the bell icon which is there next to it. Okay, you see that bell icon over there, press that. You will be notified with all the things which are happening on this channel. Whenever we come live, whenever we upload any video, anything which happens, any activity which happens on this channel, you will be notified about that. Okay, so you don't want to miss out on that. Do subscribe and press that bell icon. Okay, guys, cool. So for students who are moving from 11th to 12th standard, saying this once again, we are talking about the topic of electrostatics here. And after completing almost a lot of theory of electrostatics before Gauss's law, now this is the time to solve a few questions, a good number of questions on electrostatics. Okay, guys, so the very first question for all of you people: Let's read it and try to answer. It says that a point charge is surrounded symmetrically by 6 identical charges at distance r, as shown in the figure. So what you see here, that there is a charge small q being placed here, and there are 6 charges which are surrounding it. And question is asking how much work is to be done by the forces of electrostatic repulsion when the point charge small q at the center is sent to infinity. So whatever is the work which is done by the electrostatic force is what we are being asked to find. And we know this from our understanding from work energy power, that electrostatic force is a conservative force, and work done by any conservative force is equal to the negative change in the potential energy of the system. Yeah. So all we have to find out is U final minus U initial. Put a minus sign in front, or simply U initial minus U final. You know that initially the charge particle is here, say at point P, and finally it is going to reach infinity. So obviously its final potential energy is going to become 0. Okay, this value is going to become 0 at infinity. So all you have to do is find out the value of Ui, and that is basically the work which is done by, numerically, the work which is done by all the forces which are acting, whatever is the energy of the system, by the work done by all the forces which are acting on this charge particle while taking it from this point till infinity. Okay, so let's find out the potential energy of the system. As you know that this charge particle is at a distance r from all the charges, so all you have to do is write the potential energy of this charge with any one charge, and that comes out to be k q1 q2 by r. And we are sorted because this is the energy which is stored by this charge with one of the charge, and we know that energy is a scalar quantity, so such 6 terms are going to be there because the charge which is placed at the center is storing this potential energy with charge which are placed on the circumference of this imaginary circle. So guys, as per the options, if we have to go, let's write k as 1 upon 4 pi epsilon naught, q into q is q square by r. So it is 6q square upon 4 pi epsilon naught r, and looks like correct answer is option B. So that much amount of work is required by the electrostatic forces of repulsion in order to send the charge at the center from the center of the circle to the infinity. Okay, cool. Now, next one, guys. This says that in moving from A to B, say this point is, okay, in moving from A to B along an electric field line, the electric field does a work of 6.4 into 10 to the power minus 19 joule. Okay, and this is done on an electron. So if phi1 and phi2 are the equipotential surfaces, so these two are basically equipotential surfaces, we have to find out the potential difference Vc minus Va. If you will see guys properly, the direction of electric field, as we know, is always towards the decreasing potential. The electric field lines will always go from higher potential to lower potential. So surely we can say that the electric field lines are going from phi2 to phi1. So that is basically telling us that value of potential Vc is greater than the potential Va. So Vc minus Va is definitely going to be a positive potential. Okay, so all we have to do now is find out the value of work done per unit charge if I take the charge particle from surface C to surface A. So let's do that. So this delta V is going to be work done per unit charge. How much is the work done? It is 6.4 into 10 to the power minus 19, and the charge is charge of electron because that's the particle which has been taken from one point to another, which should be taken from one point to another in fact. So this gets cancelled and we get the answer as 4 volt. Okay, so remember guys, here the information is given to confuse you that the work done in taking the charge particle from point A to B, while the direction is given as B to A. So it does not matter A to B when you are going to take, whatever the work will be, that will be negative, and what you are getting is from B to A is what you are bringing, or say from point this to this, from one equipotential surface to the other one. That is what electric potential is. It is nothing but the work done per unit charge. Okay, so the answer comes out to be option B. Okay guys, now this one, it says that 2 point charges minus q and plus q by 2 are situated at the origin and at point A comma 0 comma 0, and that means you can say particle is placed at x equal to A. So this is placed at origin, this one is placed at x equal to a, and we have to find out the point on x-axis where the electric field vanishes, or you can say where the value of electric field becomes 0. So if we go along, say, this line, considering it to be x-axis, so I'm assuming that this point is origin, let's call it 0 comma 0, and this is where your charge minus q is placed. Okay, and say this is the point where charge q by 2 is placed, and this point is a comma 0 comma 0. Okay, and say this is the point where we want to talk about the electric field becoming 0. Okay, from the distance from the origin is to be found. So this gap is a, and say this gap is d. So what we are interested in is x, which is equal to a plus d, how much this value is going to be. But very surely, if we look at the electric fields because of both the charges, you can see that at this point, the electric field because of positive charge will try to make point P have an electric field towards this direction. And let me give it name as point A also. This as O and this as A. So this is electric field of A, and negative charge will have electric field EO, that is towards the origin. Yeah, because it is a negative charge. And because we are talking about this point P having no electric field, so we can say that electric field at P will be 0. And that is possible when both the electric fields are balancing or cancelling out each other. So E due to O should be equal to E due to A, then only electric field vector at P will be 0. So E due to O is KQ by A plus D square. Yeah, not writing minus q because we are talking about the magnitude of electric field. Okay, and this is k q by 2, and it is at a distance d, so this is d square directly. So you can see that k q get cancelled, this 2 comes down, so I have a plus d the square equal to 2d square, or we can say a plus d equal to root 2d, or though this is what we are looking for, by the way, but the answer is not in terms of d because that is what we have assumed. So a comes out to be root 2 minus 1 into d, and you can see very clearly that d comes out to be a by root 2 minus 1. Okay, people, so let's try to find out the value of a plus d now, which is basically what we are looking for. So a plus a by root 2 minus 1. Let me take a outside. So I have root 2 minus 1 plus 1 divided by root 2 minus 1. Okay. So minus 1 plus 1 gets cancelled. We have root 2a divided by root 2 minus 1 as the location of point P where electric field will become 0, and that is option C as the correct answer. Okay. Great. Awesome, guys. Try to keep on solving along with me and keep telling me the answer in the chat box or in the comment section. Now this one, guys, this says that charge of value 10 by 3 into 10 to the power minus 9 are placed at each of the four corners of a square of side 8 centimeter. We have to find the potential at the intersection of the diagonals. So if I say that this is how the charges are being placed at the corners, and this is the point which is at the center, and 8 centimeter is the side length, so we can say that this is going to be half of that, and this gap is going to be 4 root 2 of the center with respect to all the corners. So all the corners are at a distance of 4 root 2 from the center, and all the corners have a charge, say q. Okay, so we can say that because potential is a scalar quantity, so the net potential at O is going to be 4 times the potential kq by r, which is the potential due to a single charge. So this is 4. We know that k is 9 into 10 to the power 9. Charge value is given to us as 10 by 3 into 10 to the power minus 9. And let us divide this value by r, which is 4 root 2, and that too in centimeter. Okay, so 4 root 2 into 10 to the power minus 2 to convert it into meters. So you can see that this 4 and this 4 get cancelled. This will also cancel 3. So 3 by root 2 and 10 to the power 9 minus 9 got cancelled. This 10 is already waiting. This 2 goes up, 10 to the power 2 goes up. So overall it is 10 to the power 3. If I rationalize, I have 3 root 2 by 2 into 10 to the power 3, which looks like 1.5 root 2 into 10 to the power 3, or in other words, it is 1500 root 2 volts. That is the potential of the center of this imaginary square. Okay, guys, means the correct answer is option B. Interesting, isn't it? Good. Remember, potential is nothing but work done only, but per unit charge. So you can simply just add the values. Now this one, guys, it says that a charge minus Q and another charge plus capital Q are kept at 2 points A and B respectively. Okay, so say this point is A, this point is B. At A I have minus Q charge, at B I have plus Q charge, and they are say separated by some distance L. Okay, that's what they are saying. Now keeping the charge plus Q fixed at B, the charge minus Q is moved to another point C such that ABC forms an equilateral triangle. Okay, so let's think of an equilateral triangle here like this. So this length is L, this is L, and now you have taken this minus Q charge here. So your charge particle has gone from point A to point C. Okay, guys. So now the question is asking us to calculate the net work which is done in moving the charge minus Q from point A to C. So obviously the work done is nothing but the change in potential energy, which is U final minus U initial. If we look at U initial and U final, let's see what do we get. So U initial is K capital Q small minus q by L, and if you look at U final, they are still at a distance L, so K capital Q minus small q divided by L. What's the change that you see? I don't see any change. That means work done, which is equal to change in potential energy, is nothing but 0, because there is no change in the potential energy because charges are still placed at the same separation, but at some other location the charge has been placed. So the correct answer is option C. Okay, guys. Okay, cool. Let me come back to the same color that I prefer usually. Yep, that's red. Now this one, guys, it says that an infinite line charge, an infinite line charge. So you have a very long infinite charge which has say positive charge on its surface, or say that is basically what charge is. And the field due to this at a distance r, if you write say at point P, the electric field is given as 2k lambda by r. Okay, we know that. So question is asking us to calculate the value of lambda, where E and R, both of the values are given. So lambda becomes ER by 2k. Okay, so E is given to us as 7.18. Let's call it 7.2 roughly into 10 to the power 8. R value is 2 centimeters, so 2 into 10 to the power minus 2, and this thing is divided by 2, and K is 9 into 10 to the power 9. So you can see that 2 and 2 get cancelled, and this 7.2 I'm writing it as 72, and overall in the numerator 10 to the power 8 becomes 10 to the power 7 now, and 7 minus 2 is 5. This is divided by 9 into 10 to the power 9. So this cancels at 8 times. So answer is 8 into 10 to the power minus 4 coulomb per meter. So let's have a look at the nearest possible answer for this. If you will see, all of the values are 10 to the power minus 4 only, but the nearest value to 8 is option B. Okay. So what I'm trying to tell you here is that not every time you have to do the exact calculation, especially when you are preparing for exams like JEE or NEET. Okay, rough calculations usually help. Okay, cool. Now this one, guys, this is the question from JEE 2005. So the question says that two thin wire rings each having a radius r are fixed at a distance d apart with their axes coinciding. That means this is how the rings are being placed. Okay, so their own radii are given, that is capital R, and their centers are at a distance d. So the charge on the two rings are given. This is plus capital Q and this is minus capital Q. So we have to find out the potential difference between the centers of the two rings. So let's call the center of this one as A and this one as B. So obviously I'll require the separation of both the rings from the other ring center. So if this is D and this is R, this is R square plus D square in under root. Okay guys, so let's try to write down the value of VA. VA is the potential on first ring's center. So because of its own charge, the potential is KQ by R, because all the charges on the periphery of the ring are at the same distance R. Okay, and this has negative charge. So all the particles of this ring are at a distance under root of R square plus D square. So minus KQ. Why minus? Because it is negative charge. That's why negative potential, divided by the separation, that is R square plus D square in under root. Okay. Next is VB, that is the potential at this point B. So because of its own charge, it is minus KQ by R because it has negative charge, and the positive charge is at a distance under root of R square plus D square. So KQ by R square plus D square in under root. Okay. Now we need to find out the potential difference. So if I try to find out VA minus VB, you can see that this value minus this value will become 2KQ by R, and this minus this will become minus 2KQ by R square plus D square in under root. So if I take 2KQ outside, what do I get as delta V? I get it as Q by 2 pi epsilon naught. Yes, K is 1 upon 4 pi epsilon naught. There was a 2 also waiting. So this is what I get outside, and in the denominator, in the bracket, we have 1 upon R minus 1 upon R square plus D square in under root. Okay, guys, the only thing that I want to warn you again and again is that do not deal with potential as a vector quantity. Don't think of the direction here, because potential is nothing. I say this again and again. Potential is nothing but work done. It's just the work done in making a 1 coulomb charge move from infinity to a given point in the influence of the electric field of a third charge or the other charge. Okay, so that's why no vector directly, vector directly the value of potential due to all the charges which are present. Okay, hope you understood. The answer came out to be option D. Now this one, guys, it says that two charges 3.2 into 10 to the power minus 19 and the same negative charge are placed at a distance 2.4 meters from to form an electric dipole. Now it is placed in a uniform electric field of 4 into 10 to the power 5 volt per meter. We have to find out just the electrical dipole moment. Okay, that means a lot of information is given which is not useful. We have to find out the value of the dipole moment, which we know is nothing but the value of one of the charge multiplied with the separation between the two charges. And what is a dipole? You know that one charge is plus q, other charge is minus q. They both are separated, say, by a distance L. So that dipole moment is q into L from negative to positive direction. Negative to positive charge, by the way. Okay. So the value of charge is 3.2 into 10 to the power minus 19. Separation is 2.4. So when you multiply this, this will come out to be 7.68 into 10 to the power minus 19 coulomb meter, as simple as this. Okay, rest all the values are to confuse you, to calculate, to make you calculate the value of torque instead. Okay, so the answer comes out to be 7.68 into 10 to the power minus, sorry, not this but this, minus 19 is what the correct answer is. Okay guys, great. Now this one, so in a region of electric potential, the value is given of electric potential. Okay, 2x plus 2y minus 3z, we have to find out the value of the electric field. Looks like a doable one. Okay, we know that electric field is nothing but minus of dv by dx I cap minus dv by dy j cap, and minus dV by dz k cap. Okay, so this expression will try to differentiate once with respect to I cap, or you can say x axis, or you can say with respect to x. Second time we'll try to differentiate with respect to y, then with respect to z. Okay, so let's go ahead. So when we differentiate with respect to x, we get the value taking the minus outside. Differentiation of this entire term with respect to x will only give me 2, and an I cap I'll write because these two will not give you any value other than 0. Similarly, with respect to y, we'll get the value of this as 0, this as 0, and only 2 comes. So 2 j cap. And when you differentiate with respect to z, this becomes 0, this becomes 0, and this becomes minus 3 k cap. And mind you, there is a minus sign waiting outside. So the electric field comes out to be minus 2 I cap minus 2 j cap plus 3 k cap. Okay, so that's what is the correct answer for the question, which is option A, minus 2 I cap minus 2 j cap plus 3 k cap. You got that? Guys, that's great. Keep it up. Now this one, guys, this one says that an electric dipole made up of positive and negative charge, each of 1 microcoulomb, are placed at a distance of 2 centimeter apart. If the dipole is placed in an electric field of 10 to the power 5 Newton per Coulomb, then the maximum torque which the field can exert on the dipole if it is turned from 0 degree to 180 degree. We know that torque is given magnitude wise as Pe sine theta. Yes or no, guys? So the value becomes maximum when theta is 0 degree. Numerically it is 0 or 180 degree. So let's calculate it. So for this, it is P into E that we are looking for, which is Q into L into E. Okay, what is the value of charge here? It is 1 microcoulomb, so 10 to the power minus 6. Separation between the charges is 2 centimeters, so 2 into 10 to the power minus 2 to convert it into meters. And electric field is 10 to the power 5 Newton per Coulomb. So I have 2 into 10 to the power minus 6 minus 2 plus 5, and that looks like the answer is 2 into 10 to the power minus 3 Newton meter. That's basically the maximum torque when the dipole will be rotated from 0 degree to 180 degree. Okay, great, guys, awesome. Now this says that what is the work which should be done or must be done to rotate the electric dipole through an angle of theta with electric field if the electric dipole moment P is placed in a uniform electric field with P parallel to E. So initially this is basically the situation. This is your electric field, this is your dipole moment. So initial angle is 0 degree. After that the electric fields remain this, and the dipole is rotated by an angle of, sorry, not 45 degree but theta. So this is P and this is E. So theta 2 is theta. And we are being asked to calculate the work which is done by the external agent, and we know that work done is equal to the change in potential energy, which is given as PE cos theta 1 minus cos theta 2. This is what we learned already in our classes. Okay, don't worry if you are on the channel and on my session for the first time. Towards the end I'm going to tell you how can you watch and how can you cover up for all the topics which we have done in this chapter before this. Okay, so all the lectures that you have missed, I'll tell you how you can cover it up. So stay tuned, I will give you the answer. Okay, guys, so this is P into E, and the first angle is 0 degree and second angle is theta. So cos 0 is 1, we know that. So work done comes out to be PE 1 minus cos theta. That's basically our answer to the question, which looks like the correct answer is option A. Okay, guys, very well, guys. So this one, it says that electrical dipole moment of combination shown in the figure is to be found. Now what do you see here, that these four are the charges which are placed on the corners of a square with three charges as positive and one of the charges as negative charge. To consider that these are creating three dipoles, so one dipole will be from this negative to this positive charge along x-axis, the other dipole will be from negative to positive charge along the y-axis, and the third dipole will be somewhere along the diagonal of the square itself. So if we say this is P1, this is P2 and this is P3, then you know that P1 and P2 will be equal in magnitude and will be equal to Q into A, right? That's basically the value of the dipole moment here. But if you look at the side of the diagonal, so diagonal, as you all know, is going to be root 2a. So P3 is going to be Q into root 2a, which is the separation between this charge and this charge. Okay. So guys, if I say that this is the dipole P1, P2 as P, and this dipole you can see is clearly root 2p, then what the situation is, if you look at P1 and P2 here guys, both of them are equal and their resultant is going to be root 2p. Two vectors which are inclined at 90 degree and have equal magnitude, the resultant is under root of p square plus 0. So that is under root of 2p square or root 2p. And the p3 is already existing in that direction also. Yes or no? So the net resultant PR is going to be magnitude wise root 2p plus p3, and fortunately p3 is also root 2p only. So the correct answer of the resultant dipole moment is 2 root 2 p, which is basically 2 root 2 q into a. Okay guys, that's our correct answer, option B. Okay, now this one. This question says that 6 negative equal charges are placed at the vertices of a regular hexagon, and you can say that at the center 6 q charges placed, and the electric dipole moment of the system is being asked. So if you look at any two diagonally opposite charges, you can see that the center charge is creating dipoles with all the charges placed on the corners of the hexagon. So this negative and this positive charge will have a dipole moment like this of same magnitude P, and diagonally opposite charge is also creating a dipole moment of the same magnitude in the opposite direction, and both of them are vectors which are equal in magnitude and opposite in direction. That simply means that these two vectors are going to cancel out each other. Now you can guess what is happening with all the charges. All the dipoles which are being created, they are equal in magnitude and opposite in direction. So that's why the net dipole moment, being a vector quantity, will come out to be 0. Okay. Okay, now this one. A question which has come in JEE 2011. So let's read the question, everyone. Question says that two positive charges of magnitude q are placed at the end of a side, say side 1 of a square of side length 2a. Okay, so let's consider a square here, and on this square what is happening, you have a q charge here and q charge here. This is our side 1 of side length 2a, and on side 2 what is happening, two negative charges of same magnitude are being placed. So what is happening, let me place negative charge here. So this is minus q, this is also minus q. Now what you are doing, starting from rest, if a charge capital Q moves from the middle of side 1, so this is the middle of side 1, from here, say point A, you're going to take it to the center of the square, which is this point. Okay, so this point is B, which is going to be at a distance root 2A. As you can see that these side lengths are A and A. Okay, and if you try to find out the location of point A from this, so this value, you can check this triangle. I'm talking about A, this point and this point, a right angle triangle. So this is A, this is 2A, so this is root 5A. Okay guys, the question is asking us to find out the kinetic energy at the center of the square is going to be how much if you make the charge move from point A to B. So guys, again the basic concept goes back to work energy power, that the gain in kinetic energy is going to be the loss of potential energy only. So all we have to do is find out the value of initial and final potential energies difference. Obviously, if there is a kinetic energy being gained, that's why the initial potential energy is more and the final potential energy is less. Okay. So now what? Let's write down the initial potential energy. If I write for these small q charge for A, that is basically UA also I can write, and final is UB. So when the charge capital Q is placed at A, K small q capital Q by A, and such potential energy is stored by two charges. So this is 2kq capital Q by A, and the potential energy that is stored by minus q charges is going to be negative, and again two charges are there, so that is k small q capital Q by root 5a. This gap is root 5a from here till here. Okay guys, and now when the charge reaches the center, you can see that all the charges are at the same distance root 2a. So the amount of energy that is, or you can say the amount of potential at B is 0. VB is 0. Potential value at B point is 0. So that's why the overall potential energy at B is going to be 0. Okay. So now let's find out the value of the final kinetic energy. That value comes out to be, if I take uh, K outside, which is 1 upon 4 pi epsilon naught, 2 small q capital Q by A comes out, and inside I have only 1 left, and here I have 1 by root 5 left. Okay guys, so what do I get? Looks like the correct answer is option D. Yep, the correct answer is option D, that is 1 upon 4 pi epsilon naught 2 small q capital Q by A and bracket 1 minus 1 by root 5. Okay, cool. Now this one again, a JEE question, came very recently in 2019. Question is very simple. It is giving us a graph here but doesn't tell us which quantity is being mentioned on y-axis. But yes, it is given with respect to a distance r from the center of O. So this is, say, the center of that object. We don't know what that object is. We have to judge. So which of the options do you think is going to be correct? Option A says that electric field of uniform charged sphere is being represented on y-axis. So if this would be electric field, then electric field does not remain constant inside the sphere. So obviously this cannot be the answer. Okay, next electric field is option D. So electric field of a uniformly charged spherical shell. So outside looks good, but inside that value is 0. So again, this value cannot be correct. If we look at potential, potential of a uniformly charged solid sphere is not constant inside, rather it is continuously changing like this. So this is also not the correct answer, but yes, looks like answer is option B, where potential of a uniformly charged spherical shell it is. So spherical shell whose radius is r naught has some positive or any charge q. So whatever is the value of the potential at surface, which is kq by r naught, remains inside also the same, and after that the potential varies inversely with r. Okay guys, something I'm sure you guys have easily able to figure out. Now this one also from JEE 2019. This says that an electrical field of 1000 volt per meter is applied to an electric dipole at an angle of 45 degree, and the value of electric dipole moment is given to us. So what is the potential energy of the dipole? We know that potential energy of the dipole in general is given as minus Pe cos theta with respect to the stable equilibrium, where we consider its potential energy to be 0. Okay, so the value of potential energy at an angle 45 degree if we want to find out. So the value of dipole is 10 to the power minus 29, putting up all the values here. Electric field is 10 to the power 3, and cos 45 degree is 1 by root 2. Okay, so 1 by root 2 is roughly 0.7, and this looks like 10 to the power minus 26. So overall it is minus 7 into 10 to the power minus 27 joules is what we get as the answer. Looks like answer is option B. Okay guys, great, awesome. Now this one is your homework question, everyone. A charge capital Q is distributed over 3 concentric spherical shells of radii A, B and C. Okay, with A being the smallest. So like this the situation is given. This is with radius A, radius B and radius C, and surface charge densities are given to be same, say sigma. So the total potential at a point at a distance r from the common center, which is inside the sphere also. That means somewhere here, if point P exists, then find out the potential at this point P. And the important part is answer is not in terms of charge density, rather it is in terms of capital Q, because if this is Q1, this is Q2 and this is Q3, Q1 plus Q2 plus Q3 is given to you as capital Q. So try to find this, guys, and do tell me your answers in the comment section, not in the chat box, because I would want to read them later on, and obviously I will get back to you people with the correct answer also. So stay tuned. Okay, guys. Now, as I told you, for people who are new on the channel, do not know when the electrostatic session starts. So guys, it started in the month of April. It's been almost more than a month here, and I'm sure that you are interested in covering up for the lectures that you have missed. So how can you? Let me tell you how can you cover up for that. So in order to cover it up, guys, all you have to do is on this channel, go to the playlist, and in the playlist look for this. Yes, 2021 is what you're looking for, and you will find each and every lecture of electrostatics which is being done so far, including this one also. Okay, I hope it's being helpful for all of you. Okay, now if you are interested more than that in assignments and their solution, more study material and daily updates, let me offer the Telegram group of Vedantu, in which you can get a lot of information more than what happens on YouTube. Okay, so people, follow this link which is available in the description as well, and yes, I will see you soon. If you guys enjoyed this lecture, guys, enjoyed the problems that we have solved, do tell me in the comment section if you like to solve the questions with me. Do hit that like button. Okay, share with your friends so that they can also study with you, they can also take the advantage of these awesome sessions which we are taking on the channel. And if you are regular on the channel and still not subscribed, I would recommend you to subscribe to the channel right now by pressing the bell icon as well, so that you are notified every time when I come live, or any of the teachers who are your master teachers when they come live. Okay, so guys, with a promise that even during the lockdown your learning won't stop, I will take your leave and I'll see you very soon. Till then, keep studying, keep enjoying, keep smiling, and more importantly, stay safe. Bye bye, guys.